I made Ted from Black Ops 2 Zombies. I'm going to show you exactly how I did it. So I'm just looking through here a little bit to see some inspiration for the way Ted is going to move. So we can see he's already got head rotation. Some eye flicker left and right. Mouth moves up and down. Okay, so I'm assuming it's basic head, tilt, yaw, and pitch. So we can do that. All right, that's simple enough. So after doing a bit of research, I was able to find this. Creative Commons, blah, 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 blah. Okay, human head orientation modeling used for head pose estimation and designing a 3 degrees of freedom neck head robot. So this is gonna give us, it's gonna give Ted the ability to move his head in the Z-axis, X-axis, and Y-axis. Head roll, pitch, and yaw. So, beautiful. And the way that this is going to work, let's say this servo rotates a certain way. It'll send the force up through the link and then through the head and force that to move in a certain direction. Now let's say the other servo moves the other way. It'll move the head in the other direction. It'll tilt. That'll allow it to tilt left and right with the servos moving in opposite directions. Or if the servos both rotate upward, the head would then look down. And then I plan on having a servo right in the middle to make the head look left and right.
Many unbearable hours later.
We now have a model that's ready to print. Okay, so we have the adapters that I'm going to put on the servo horns because holes on the servo horns are not big enough for these linkage bolts. And then here we have the shell for the ultrasonic sensor for him to react to people that will walk in front of him. Then we have the mechanism that'll move the eyes left and right. And here we have a closer look at the eyes. This part's going to be printed by clear PLA, so I can get some light diffusing through it. Oh. Okay. And here's the jaw. You can see on the right side, that's the servo that'll control it. And on the other side, we'll have a loose pin that'll allow it to rotate freely. So it'll just have one point of control, which shouldn't be a problem for something this lightweight. And here we've got a universal joint that the main head plate will sit on. And this will allow it to move in 2 degrees of freedom. And with that, we can finally stop yapping and start building. So just for the sake of printability, I had to print some of these parts separately, such as this main plate that's going to be connected to the universal joint. And I'm just going to go ahead and glue this in. And here we have that little box you saw. I'm going to go ahead and mount the servos in there. Just pop them in one by one. So I'm going to use a servo horn to mount the neck onto the main servo that'll allow for head rotation. Just like that. Throughout this video, you'll see that I have very bad luck when it comes to small screws. But we're going to get it done one way or another. So here, even in this unfinished state, you can kind of get an idea how the head is gonna tilt and move up and down on the universal joint here. So let's go ahead and attach these linkage rods. Again, for better printability, I had to separate some pieces, and this is going to be the main part that'll hold the servo that controls the jaw. And I'm just gluing that in right now. And even with the glue, I like to add a little bit of plastic welding for a little bit of redundancy. And there's the jaw servo in place. Snug. And you can kind of see Ted's face coming together a little bit. Now I made sure to model a little bit of a hole in the model before attaching the servo horn so I know exactly where to mount it. Now let's work on the eyes. Here you can see the clear PLA piece that I want to use as the, I guess the iris, the pupil. But anyway, I'm going to try to position it and go ahead and glue it in so it's permanent. And same with the other. Now these aren't the LEDs I'll be using, but I just wanted to show you a little bit of the diffusion through this clear PLA piece. It's really, really good. It's better than I expected. So this will work flawlessly for his eyes. Now I'm attaching the main levers that'll control the eyes. Here I'm just doing a little bit of plastic welding. And as always, some extra adhesive for redundancy. Now I'm going to use a paper clip as the pin that'll act as the hinge in this bar that'll control both eyes at once. And it'll attach onto the servo horn. Alright, so we got the eyes on their pegs ready to go. Now I just got to get the bar in there. So far so good. Now I want to demonstrate a little bit. As the bar moves left, eyes look right. As the bar moves right, eyes look left. Now I'm going to be attaching the ultrasonic sensor shell. In the final model, this is going to be attached to the box as is, but I just didn't have the foresight for this. So I'm going to glue it and of course weld it for redundancy. Now something a little more interesting. We're finally attaching the linkages to the servo horns to get the full head set up. Okay, so here you can see a general overview of my circuit. We've got the 7.4 volt battery connected to the step-down converter, which will step it down to 5 volts. And that'll connect to the power distribution terminal, which will then distribute power to the peripherals. And there's just a time lapse of me setting up all the servos and connecting them to power and the Arduino controller. All 5 servos are finally working at once. So skipping ahead a little bit, I wrote some code just to see how the head can move in each direction. So as you can see, up, down, tilting left and right is pretty good, but it's the rotation left and right that's a little bit stiff right now. But yeah, I'm happy with it for now. So I'm gonna move on to the sounds and the sensor, and then I can iron this out a little bit later. Here I'm setting up the DF player, and in case you don't know what that is, it's basically just a small MP3 player device that'll play whatever MP3 files you have on an SD card that you insert into it. You can make it so that it plays whatever audio file you want whenever, let's say, a sensor is triggered. All right, so Ted's gonna need to be able to speak. And what better idea than to go online and look for audio clips of Ted speaking. Not this Ted. Black Ops 2 Ted. So this is one of the few videos I found with very clean clips of Ted speaking with no movement, sounds in the background, no gunshots, no music. So I'm gonna go ahead and use this YouTube to MP3 tool I found online to convert this to an MP3 file. And then later, I'll cut up these 5 clips into separate MP3 files to play at random whenever the sensor is triggered. Now, speaking of the ultrasonic sensor, we finally got it set up. And I want to demonstrate its functionality through the serial monitor in case you don't know what it does. So it basically uses sound to calculate how far an object is. So as I move my finger closer and further away from the sensor, you can see the distance reading increasing and decreasing as I do this. And the way I want this to work is so that whenever a reading of 30 centimeters or less is triggered, I want Ted to play a random animation and a random MP3 file. So at this point, I'm looking at Ted and realizing he needs a body. So let's get to work on that. So skipping ahead a little bit, I had to print out his body in 2 different halves because even the H2S wasn't big enough to print this whole thing at once. Then I'm just doing some plastic welding along the seam to make sure everything's secure and permanent. And as always, I like to weld and glue my pieces for redundancy. So now we can go ahead and squeeze the head onto this here platform. Made it a tight squeeze because I really want this to be nice and snug and permanent. And there we go. And now we have the most tedious portion of the process, the programming. And better yet, in C++, because that's what Arduino's based on.
C++ is absolutely atrocious. First of all, there's like 20 different ways to initialize a variable. And there's so many rules and edge cases around initialization that somebody wrote a 300-page textbook solely on this one topic.
But anyway, here's my code, which will be available for completely free on my Patreon, along with 3D print files and more detailed instructions on the build. Now at this point, I programmed the sensor functionality as well as the MP3 player functionality, and even some idle animations. Now let's see what someone suspecting trick-or-treaters might get a taste of. Now by this point, the only thing that really needs to be done is adding additional MP3 files and dressing them up. So since I couldn't find any bus driver uniforms, I just got this police officer uniform. It looked pretty similar to what Ted wears. And now my favorite part of these projects, taking the whole thing apart and painting it. So I didn't record myself painting the head, but it's essentially the same process. So over a base coat of chrome, I paint on some brown, wipe it off and stipple. Then I do the same with this orange paint. Then I do the same with this black paint. and then add another thin layer of the orange. And after that, we have a decent, worn out metal, rustic look. So we can see that Ted has this little patch on his hat that reads Bloodhound. He's also got this name tag, so we're gonna go ahead and model those in Fusion. And wrapping up the Fusion model now, we now have the tag and the badge ready to go. Anyway, that's a wrap. Hope you guys enjoyed the video. I had a blast making Ted. And don't forget to like, comment, and subscribe. But before I go, some closing remarks. You might have noticed that in neutral mode, this one eye does not work. I have no clue what's going on. Probably an issue with the circuitry, maybe the grounding. I don't know. Because whenever the battery is turned off, that light turns on. Likely an issue with the circuitry. Not entirely sure what it is, but.
Hey, asshole, I'm telling you to stop or I'm throwing you over the cliff.
When he's triggered, both red lights turn on, so I don't know what the hell is happening. Maybe one of you guys can figure it out if you take on this project, I don't know. But anyway, as I said before, resources, CAD files, instructions, circuitry diagrams, all in my free Patreon. So if you guys want to take a crack at it, you're welcome to try. Anyways, that's all. Hope you guys enjoyed.